In this session, we have a look at Truelight color spaces and ACES. In the last session, we saw the requirements and problems we are having today with regard to digital image reproduction. ACES and Truelight color spaces are concepts which addresses all the previous discussed issues. We start with ACES, as ACES is a more specific solution. Once we understood ACES, Truelight color spaces is introduced as a more flexible and general color management system. All Filmlight products use Truelight color spaces as the internal color management technology. And this is the ACES color management framework that tries to address all of the various problems. And as you can see, it is not a naive solution but relies heavily on color management. There are three major building blocks or color transformations in this framework. The IDT, which stands for Input Device Transform, the RRT, which stands for Reference Rendering Transform, and ODT, which stands for Output Device Transform. The IDT addresses all the input challenges. The IDT transforms each image input type individually into one common color space by undoing the camera manufacturer's transfer function, basically going back to sensor linear, and then scale, translate, rotate the color spaces. Remember our example with the maps, into one very big color space. After this transformation, there should be no difference between the cameras in terms of color management. The differences left over are the real differences between the various camera properties. So as a starting point for grading, they are much closer together. Also should a grading operation react similar no matter where the input came from. With the IDTs, mixing cameras should be less a problem. The resulting common color space is called ACES. It has a very big color gamut, bigger than any real camera gamut. Its transfer function is linear per definition. Linear like the digital sensor were in the first place. The RRT addresses workflow problems and implements the pleasing color reproduction. The RRT stands for Reference Rendering Transform and addresses the workflow problems and implements a pleasing color reproduction. You can think of a generalized, modern, open source generic film lab that tries to preserve all the color science efforts, which were previously developed for film reproduction. This transformation has technical but also creative or perceptual aspects. It tries to introduce a certain kind of color rendering aesthetic, but in a much broader way than film did. This is the open transform from high dynamic range color spaces to low dynamic range color spaces. The idea is that each ACES compliant application has the same way of representing high dynamic range data on a low dynamic range display. Referring to our previous analogy, everyone has the same glasses on. The ODT stands for Output Device Transform, and it has the same concept as the IDT. It brings the output of the RRT into the specific display color space. When you work with ACES data, you always use the RRT and a specific ODT in combination to view your data. ACES includes all colors a human could perceive or a camera could capture. In theory, the dynamic range is not limited. In practice, you have more than 20 stops without losing any precision in a 16-bit half-float image, so plenty of headroom for modern cameras. ACES tries to achieve a lot of good things. First of all, you have a so-called indirect output preferred grading, meaning you have both what you see is what you get on a low dynamic range display and high dynamic range data underneath. It is an open standard with no secrets. It tries to establish one workflow for both visual effects and the eye. Actually, all speak the same language. It tries to reduce complexity for visual effects workflows. You can build a consistent color pipeline from onset, dailies, editorial, visual effects to post using ACES. You can use it for any production, no matter if it's cinema or television. Mixing cameras is getting easier with ACES. It also tries to raise or maintain the overall image quality by conserving the efforts from the film days. If the standard is widely used and accepted, it could become a good archive candidate. But on the other side, you should also be aware of 2 points. Due to the RRT, which sits at the end of the process, ACES implies film style grading. For colorists which were used to DI work, it will feel very natural. Anyway, if you are telecine style or video style colorist, grading in ACES will feel much more different to you, as the grading style is very different. The starting point is different, the tools work differently, compare film and video grade, and many more. We at Filmite still consider the use of film style grading technique because it has some advantages compared to the other, but we also understand that it might feel distracting in the first place. If you were used to grade in a different style for years, we would not recommend a telecine colorist to dive into ACES directly on a high pressure or demanding job. First, do some practice and understand how different the tools react. We are providing some sample scenes and material along this package so that you can practice before you start a job. The other thing to consider is that actual implementation of ACES. A lot of software tools use lookup tables to do all the needed color transformations. As for some transformation, lookup tables have the right precision, some care should be put in the design of the lookup tables. Lookup tables were initially not designed for handling a variety of high dynamic range color space transformations. Other grading system manufacturers try to build new and better LUTs to accommodate for the present demands. But we at Filmlight went a different path. We believe it's not about designing better LUTs, it's about designing something better than LUTs. Which brings us away from ACES to Truelight color spaces. Before we dive into Truelight color spaces, I first want to explain some of the motivation to build a future-proof LUT-free system. Which drawbacks does a LUT-based system have? Let's assume that there is a lookup table, which eliminates all the technical drawbacks of lookup tables, like lack of precision, concatenation, routing errors. And there are some attempts in the industry to address some of them. There is also operational problem with lookup tables. A LUT per definition is always a transformation from one color space to another, like a route from one point A to point B. So imagine you have 4 color spaces and want to convert into one common color space like ACES. You end up having 4 LUTs. If you now want to convert from 4 color spaces to 2 other color spaces, you end up having 8 LUTs. Imagine you want to have the possibility to convert from 20 color spaces to 20 other color spaces, you would need 400 LUTs. Then some of them have different display rendering transforms included, so you need 400 per display rendering transform. Fast it will grow to a LUT repository with over 1000 LUTs to choose from at every step in the workflows. Errors and mistakes are inevitable, and the amount of LUTs raise with every new color space you add. In Truelight color spaces, you do not design lookup tables, but color spaces. The actual transformation is done for you on the fly in a GPU shader floating point engine based on mathematical formulas rather than on LUTs. It's a system with higher precision, more flexibility, and less possibilities for errors. Truelight color spaces ships with around 40 color spaces and 5 display rendering transforms per default. To have the same flexibility in a LUT-based system, you would need more than 5,500 LUTs. Also, you as a user can specify custom color spaces and DRTs. Each color space you add would need over 250 new LUTs in a LUT-based system. Each display rendering transform you or we add imply 800 new LUTs. We at Filmlight saw that LUTs don't scale in a future-proof system. We expect more color spaces in the future rather than less. So we built an easy-to-use color management framework, which reduces complexity by gaining flexibility, once you get your head around. At the moment, Truelight color spaces know 2 kinds of color spaces: high dynamic range camera color spaces and low dynamic range display color spaces. Camera color spaces are color spaces from real digital cinema cameras like Arri Wide Gamut or Sony S-Log3 S-Gamut 3, or CG renderers like Linear Light Rec 709 coming from V-Ray, for example. There are also technically designed color spaces like ACES Linear. They are designed to store high dynamic range data in an efficient way. Typically, they are scene referred, meaning that there is no color rendering applied to them. You are able to access the light energy of the captured scene. Remember the candles example, you could say how many candles were in the room while shooting. That's why they are also called scene-referred color spaces. They are not designed to look good on a typical monitor. That's why they look odd if you view them without any color management in place. They are potentially good color spaces to work and to collaborate on a high quality standard. They are designed to keep all the information the sensor or renderer captured. They are identified within Baselight with the little camera symbol left to the name. On the other hand, Truelight color spaces knows display color spaces. These are color spaces from real displays like DCI-P3, Rec 709 or sRGB, and from virtual displays like DCI, X', Y', Z'. They have the corresponding properties of a given device. Also, some cameras produce display color spaces, typically Rec 709. The color spaces were designed to faithfully reproduce color for that given device. Typically, they are used to distribute content once all the work is finished. Now, if you want to convert from one camera color space into another camera color space, the calculations are all floating point and without loss of precision. In this example, we convert from one camera color space to another, then to another, then to another, and to another. You see that the result never changes. The same is true for conversions from display color spaces to display color spaces. Again, a short example that color space conversions are lossless if you stay on one side in the same color space type. However, to be consistent with film style grading, video style grading, and ACES, we need to insert a display rendering transform when we detect a change from a camera color space to a display color space. You can specify the display rendering transform, or short called DRT, in use in the scene settings. We learned that the DRT introduces a pleasing color rendering, which brings you nicely from a high dynamic range color space to a low dynamic range color space by compressing tone scale and colors. Every time Baselight detects that you want to go from a camera color space to a display color space, it applies a display rendering transform, defined in the scene settings. If Baselight detects that you want to convert from one display color space to a high dynamic range color space, we apply a complex inverse transformation. What I am about to show now is how I bring an image of a train shot on a Rec 709 video camera into a high dynamic range ACES Xenon log scene. Clearly we generate color data which does not exist in a low dynamic range source data. So there is a danger of artifacts being introduced as new data is synthesized. Possible artifacts may not be visible in the first place, but occur when you start modify the data in the grade. See the blue sky, how it turns magenta due to the artifacts. With Truelight color spaces, we have greatly improved our inverse transformation and we minimized possible artifacts and to gain color acuity. You could also specify a simple backward transformation, which is 100% artifact free but does not provide 100% color acuity. You can control this behavior in the scene settings. If you enable the option do not apply DRT for display to scene color space conversion, Baselight uses the simple backward functions. However, if you disable that option, Baselight uses the complex inverse transformation. In Baselight 4.4 M1, we also have the ability to exclude a single shot from the general color pipeline by using the output color space in the sequence setting. By setting the output color space to a low dynamic range color space, we basically do not convert to the high dynamic range working format for this particular shot. This becomes handy when you're confronted with variety of low dynamic range material in mix with the high dynamic range camera material, for example titles or stock footage. Okay, but how do you set up a scene properly in Baselight with Truelight color spaces? There are three major spots in the application where you identify Truelight color spaces. In the input stripe, you need to specify the type of color space for each clip in your timeline. Basically, you tell Truelight color spaces which color space each shot is. This is on the input level. Then in the scene settings, you tell Baselight what working color space you want to work in, and which DIT you want to use. These settings get really important later when I show you how to set up the 3 major grading styles. This setting determines the common grading color space. Baselight makes a color space conversion for each shot from its input color space to the working color space, eliminating the technical differences of the different camera materials. This is equivalent to the IDT concept in the ACES framework. The last spot you interact with Truelight color spaces is the timeline, cursor and render settings. Here you set the viewing or output color space. In the viewer you typically choose the color space of the device you use for grading, like Rec 709 or DCI-P3. In the rendering section you choose if you render an intermediate high dynamic range type or a final distribution low dynamic range output. So let's see how you set up a ACES compliant film style grading scene. In this scene, which we provide for you, we have the following scenario. In each input stripe, we declare the type of footage: RE Loxy Wide Gamut, Canon C500, Red Log Film Red Color 2, and Sony S-Log 3 S-Gamut 3. If you work with RAW files, you need to make sure that the RAW decode setting matches your chosen input color space. For making things easier, you have the option to put it on automatic. In this case of RAW files, we will take care of the output settings from the RAW converter. In the scene settings, we choose ACES CC and ACES RRT 1.0. In the cursor color space, we choose Rec 709 because I'm viewing the result on a Rec 709 monitor. This setup would be an ACES compliant setup. We convert each input to ACES CC on the input. This is equivalent to the IDTs, and convert everything to Rec 709 on the output using the ACES RRT 1.0, which corresponds to the RRT ODT concept of ACES. We are working in ACES CC. This is the Academy's new recommended space for color grading. It has a logarithmic tone curve instead of a linear one, so that the film grading tools react in kind of the way how they were designed. This is now a film style setup. As I am grading scene referred, I have control over the linear light energy on set. In this example, we have a normal exposed shot rated at 800 ASA, then 2 stops overexposed, then 4 stops overexposed, 2 stops underexposed, and 4 stops underexposed. By staying in the scene referred domain, I can stop up and down the light as if I would have control over the aperture of the camera. A stop in film grade is roughly 4.5 in ACCC. So to compensate 2 stops, I just pull it roughly down by 9. Looks pretty good. On the next shot, I pull it down 4 stops by entering -18. Looks good. It seems that the camera has not clipped so far. Let's see the underexposed shots. I push this one with +9, 2 stops. Works good. I see that there is a bit noise coming up. The next one is 4 stops under. I push it with +18. Well, we see that there are limits. Again, this shows pretty obviously that you should push a camera more to the higher part of the range and push it down in grading rather than underexposing it and pushing it up. If we recall the linear light theory, we see that the lower stops have noise and that the quantization is more imprecise down the scale. Let's examine how good the camera matching works. We have 4 times the same scene recorded with 4 different cameras pushed to their limits. Technically we have RE Loxy Wide Gamut, Canon log from C500, this is a Red Epic debired directly to ACES Linear, and a F55 recorded in S-Log 3 S-Gamut Cine. To compare them, we first need to balance their exposure and white balance. As we grade scene referred, we can do that in grading. For this I zoom onto the gray chip under the yellow chip. Now I pull the first shot so that the gray cuts land on roughly 0.5 in Rec 709. For the white balance, I use the new balance exposure feature in the film grade operator. This function automatically drives the exposure of the channels individually, so that the picked areas get neutral. I do that for all 4 cameras. Okay, now we can zoom out. You can see that the match is really good. Of course, as the color science is only an average transformation, trying to get a best fit, it will not work 100% perfectly. Optical elements and their different spectral properties cannot be matched 100% exact in a general way, but you see how close you can get by just correcting for the light energy falling onto the sensor. Also see how good the tone scale matches. As a colorist, you can take it to 100% match from here. Your starting point is just way better and you are using the tools how they were designed. In the scene, there is one more example of 4 different cameras and how they are set up. Try to match them only with the exposure of the film grade. You would be surprised how close you can get. If you are a film style colorist, this is all not new to you, and it works like it did in the DI style grading. Now examine the same footage in video style grading. For this, we keep the input color space and the cursor color space as they are. We are only changing the working color space. We put it on Rec 709 video. Basically on the low dynamic range side of things. What happens now? Baselight now converts on input from each input color space directly to low dynamic range Rec 709 using the specified DRT. In our case, ACES RRT07. We are working in a tonal and color compressed working environment. To gain awareness, we have added some hints in the color space journey when we detect a non-optimal setup of color spaces. Let's see the same shots. You should not use the film grade operator in this mode because it was designed to work in a HDR log environment. Typically, you would use video grade. If I try to bring down the grade, I see that I cannot recover the details. The DRT has compressed my signal much. This is clear because the display rendering transform was never designed to work on input. We at Filmlight designed a new DRT specifically for this kind of workflow. Truelight Video 1 introduces a simple color rendering but gives you enough headroom to alter the image afterwards. But you need to be aware that matching HDR cameras is way more complex working like this. So to summarize video style grading meaning setting the workflow color space to a display color space, should be used only when the input material is low dynamic range too. Then it would make sense. Typically, you work with low dynamic range footage in broadcast and some sets of commercial and TV work. For working with high dynamic range material, you would give up a lot of color information. I say it again, we at Filmlight would not recommend to put the working color space to a display color space if your footage is high dynamic range for the majority of shots. Okay, one is missing. How about the telecine grading style? Grading from the logish image until it looks good on a monitor. Let's see the same scene in telecine style. Here again we have the 4 different cameras. They all look logish, but kind of the same look, right? Let's examine the scene settings. We see that the working color space and the grade result color space has changed. What does this mean? To accommodate a telecine workflow but taking advantage from input and output color space conversion, we introduce the grade result color space. With this setting, you tell Baselight that the output of your timeline should be treated as different color space, in this case Rec 2020. We convert now all the inputs for you into one common high dynamic range camera color space. The colorist grades until it looks right on that given device. In other words, the colorist with his grades brings the material from a Cineon log Rec 2020 to a video Rec 2020 in our case. From there, Baselight picks it up for displaying and rendering, and then we can render different deliveries based on the grade result color space. For example, an sRGB or DCI XYZ delivery. This should now feel like an old school tape-to-tape workflow, but only having one input and one output. Again, with this workflow, you access the full dynamic range of your input, but you don't get all the advantages which comes from using a DRT. No soft clip, no compensation for different human perception-based effects, nothing like that. We at Filmlight don't promote this workflow, and we advise to grade in a film style way when you have a high dynamic range material. But as Truelight's color space is very flexible in its configuration, we accommodate for that workflow. And please be aware about the drawbacks when you hand the data to visual effects. You cannot give them a high dynamic range data and the intended look at the same time, as there is no general way to go from high HDR to low dynamic range. Basically, you cannot render a meaningful high dynamic range version of your graded shot because the grading itself introduces a conversion to low dynamic range. To easily set up a new scene in one of the described ways, we introduce templates in Baselight 4.4 M1. When generating a new scene, you can choose from one of the described grading workflows. Of course, you can also create your custom one. I hope you enjoyed and see you the next time.